Hi there, my name is Shreyas Gupta, and this is a short educational video about how neurons work. But before we actually dig into neurons, let's take a step back and talk about the nervous system, right? Hopefully this is something that we're all familiar with. And the nervous system is broken into two parts. The central nervous system, which mainly consists of the brain, and the peripheral nervous system, which mainly is the nerves that extend into the rest of your body. So now the difference between these two is that all of the processing of thought, information, colors, sight, sound, everything that we kind of process all happens in the central nervous system. And the peripheral nervous system really exists to send us information and then also receive information from the brain. So the sensation of touch, right? That's all a nerve in your skin that sends information all the way up to your brain that your brain processes and then perceives as touch. Likewise, if my brain wants to say move a finger, it sends a signal to the nerves in my fingers telling it to either contract or expand. So in this way, the peripheral nervous system is both controlled and also very important to the central nervous system. So now, how does this exchange of information work? Well, it happens through this thing called neurons, and we have a lot of different types of neurons. But the first one we're going to talk about is called the bipolar neuron. And the reason we're going to talk about this is because it's relatively simple compared to the other neurons. So it has an input, which we're going to call a dendrite, and it also has an output, which we call the axon. But these words, dendrite, axon, they can be kind of confusing for people who are just getting into neurobiology. So for right now, we're just going to call it the input and the output, just to keep it simple. Okay, so it receives some sort of information and it outputs some sort of information, but what are we actually receiving and outputting? Well, it's an electrical charge. Now, we call this the action potential, but you can just call this a signal or just information. But all we have to know is that the neuron receives some sort of electrical pulse or stimulation, it processes it, and then it outputs it to another neuron, which you can see demonstrated here. So the charge of electricity goes through your neurons. So our brains are actually completely powered by electricity, which is pretty freaking cool. So now, what's next? What do we want to talk about? Well, what happens if the electricity is a lot less, right? Then it's actually not able to pass through the cell. The cell recognizes that, hey, there's not a lot of electricity, so it actually doesn't output it at all. Now, this is super cool. Depending on the level of electricity or the strength of signal that it receives, it will choose either to output it or not to output it. And this is kind of the very basics of how neurons can actually compute information. But there's a lot of different types of neurons, which you can see right in this picture here. And they look vastly different from each other. So how do these neurons work? Well, we can look at this slightly more advanced neuron and see that it's a little bit different from the bipolar one that we saw before. Here, it has multiple dendrites. So each of these stems that you see protruding from the main cell body are dendrites that connect to, or I should say inputs, that connect to a completely different neuron. So here we can see on the left-hand side of your neuron, there are 5 different kind of inputs, and each of these inputs are from different nerve cells. So let's say that only one of them gives you an electrical impulse. Well then, when the impulse goes to the cell body is like, hey, this isn't that much electricity, I don't think I'm going to output it. So the impulse goes away. Versus, let's say multiple neurons start firing impulses, then they all go to the cell body, and the cell body is like, whoa, this must be super important, I'm going to output it to the next neuron. So neurons send their outputs based on the inputs they received. If they don't receive a lot of electrical input, they won't output anything. Versus, if they send a lot of electrical impulse, they will output a lot more. But wait a minute. Let's take a second, right? We've understood how neurons work in our body, but what if we could do this in a computer? Can computers start to mimic this very complicated biological process? It turns out that they can. And it's super interesting the way that we create these things called artificial neurons. So on the top, you can see what's our normal biological neuron, right? And on the bottom is an artificial or computer neuron. And you can see that they have a lot of similarities, right? They both have inputs and outputs. And this is really interesting because we've kind of modeled computers to do what our cell does itself. So now this artificial neuron also takes in these inputs, does some sort of computational process, and then relays an output. But how does this happen? This process of getting from an input to an output. It's what we call training. So it's figuring out how do we calculate that. So there's a bunch of different math we can do. What we see in regular neurons can normally be the sum of all the inputs. So the neuron will add together all the inputs, and if it's greater than a certain value, it'll relay an output. But this doesn't work for every situation. Sometimes you have to use a different mathematical function. But the process of training is all about finding out which mathematical function relates our inputs to our outputs. And by doing that, we can train our neurons to respond to certain inputs in a certain way. And when we link a bunch of these neurons together and then train them, we get what we call artificial intelligence, right? The same way that we have our intelligence, or 86 billion neurons all linked together, we can train computers to kind of mimic the same things using neurons. All right, so let's wrap this up. We just talked about a bunch of stuff. So we know that we have neurons that make up our nervous system. And neurons help us not only sense, perceive, but also kind of compute and think about the world around us. And these neurons, they work by taking inputs from other neurons, processing the electrical signal, and then giving an output to the neurons in front of them. And we also know that computers now are able to sort of mimic this, right, through mathematical operations. So we can take mathematical inputs, do some sort of calculation or computation, and then receive a mathematical output. And then by training these functions and by training these neurons, these artificial neurons, we can link them together and we can create artificial intelligences that are uniquely specialized. Now, there's a long way to go before we actually reach human intelligence, right? Now, all of these, things that are happening right now, like ChatGPT, now they're starting to hit the billions of neurons, right? We can think back to as early as a couple years ago where we had ChatGPT 2. That revolved around about 300,000 neurons, about the same in the brain of an ant. But now we're getting up into the 60, 80 billions, right? That's almost on human level of neurons, but they're not exactly on human level right now because neurobiology is extremely complicated and it's very difficult for, even the most advanced of computers to analyze it. And even when computers do get it right, it takes a lot of time. I mean, think about the average human, right? It takes decades of training your human brain to kind of understand how the world works, or even just a small part of the world. So it takes an immense amount of time and resources to train these neural networks. And there's a lot of room for improvement. So my final message, I guess, would be that there's so much more to learn, not only in our own brain, but also in the way that other neurons work. And by digging deeper into the way that our own neurons work and our own kind of brain functions and perceives and thinks, the better we can get at replicating that outside of our own brain. I think that's an extremely interesting prospect. I hope it excites you as much as it excites me. Thanks for watching, and I hope you enjoyed this video.